Hello Year 6, welcome to your maths video for Tuesday. Well done on your work yesterday on the area of triangles and parallelograms. You did a really good job. For your starter for today, I have set you another Kahoot quiz. Okay, it's slightly different to the one for last week though. It's all about area, perimeter and volume. Okay, because I think we've already got a really good understanding of those things. So I just want to recap it quickly in the quiz, go over any misconceptions that we've got, and then you'll be able to apply what you learn in the quiz to your work for today. Because I already know that you know how to answer simple perimeter, area and volume questions. So today we're applying that to answering some reasoning questions. So our learning question for today is, can I apply my understanding of perimeter, area and volume? Okay, so copy down that game pin, pause the video, have a go. Don't forget to put your real name on. Okay, some people last week still use their nicknames and then I didn't know who they were, so I couldn't send them a marvellous me. So make sure you use your real name so that I can see how well you do. I don't mind the odd emoji as well after your name. Well done to Josh last week on the mental maths Kahoot quiz, who was our top scorer. So let's see who it is today. Okay, so copy down that page and have a go. Okay, so we're moving on then to pages 52 and 53. Okay, so we're doing one page on perimeter and area and then another page on volume. Okay, so we're still in our stretch book today. Okay, so turn to page 52 and you will see it's called perimeters and areas. Okay, so your first question then says, Bella and Charlie both have rectangular swimming pools. Bella's pool measures 5 metres by 6 metres. The perimeter of Charlie's pool is 3 times the perimeter of Bella's, and the area is 3 times the area of Bella's. Okay. What could the measurements of Charlie's swimming pool be? Now, I've drawn out the swimming pools to help me visualise what these pools look like and what measurements we've got. So I've drawn Bella's pool and Charlie's pool and I've put on what we already know. So from the question, we know that Bella's pool measures 5 metres by 6 metres. Okay, so we don't know the measurements of Charlie's yet, but we do know the perimeter of Charlie's pool is 3 times the perimeter of Bella's, and the area of Charlie's is 3 times the area of Bella's. Okay, but we don't actually know the perimeter or the area of Bella's yet, so that's your first job. So the perimeter then, remember, is when we add all of the sides together. So if this side is 5, then this side down here will be 5. And if this side here is 6, then this side here will be 6. Okay, so 5 add 5 is 10, add 6 is 16, add another 6 would be 22 metres. Okay, your area then would just be 5 times 6. So that, we all know, is going to be 30 metres squared. So that's your perimeter and area of Bella's pool. Now, let's just read the question again. The perimeter of Charlie's pool is 3 times the perimeter of Ella's. So if we multiply this by 3, that will give us the perimeter of Charlie's pool. So you need to do 22 times 3, which would be 66. Okay? The area then, well, let's just put a P there so we remember that that's the perimeter. The area then was 30. 30 times 3. I know that 3 times 3 is 9. Add my 0 back on is 90. So the area of Charlie's pool would be 90 metres squared. Okay? Now let's just check back on our question because I don't think we're finished. So it says, what could the measurements of Charlie's swimming pool be? So like the measurements of Bella's was 5 by 6, it doesn't want these for the answer. It wants this and this. Okay, So if your area is 90 metres squared, you know that these two must multiply together to get 90. Okay, it must do. So for example, it could be 9 and 10, because 9 times 10, okay, so it could be 9 times 10 is 90. But will my perimeter work if they are 9 and 10? Because if that one's 9, that one will be 9. And if that one's 10, that one will be 10. So that's 10, add 10 is 20, 29. No, it's not going to equal 66, is it? So it won't work. So your challenge is to find two numbers that multiply together to get 90. And then when you add up all the sides, it equals 66. Okay? It's one of those that you're going to have to be a little bit patient with. You're going to have to maybe do some trial and error, get your purple book, make lots of notes, and have a good go. Okay? Question 2 then says, Barry buys some grass seed to cover his rectangular lawn. One packet of grass seed covers 64 metres squared, and he uses half a packet. This is important information. I've highlighted all of the key vocabulary. So it says, Barry wants to put a path around the edge of the lawn. Each side is a whole number of meters. So that just means we haven't got any decimals. Okay. What is the minimum length that the path could be? Okay, so I've drawn my lawn again, because this is going to help me visualize it. So if we know that one packet of grass seed covers 64 metres squared, and he's only used half a packet, if you do 64 divided by 2, that will give you the area of his lawn. Okay, so 64 divided by 2 is 32, isn't it? So the area of Barry's lawn is 32 metres squared. Okay? So you're going to have to figure out then what factor pairs we've got for 32. So what two numbers you can multiply together to get 32. Okay, so I'm going to write factors up here. Okay, so for example, factors then could be 1 and 32. Okay, it could be 2 and 16, couldn't it? And it could be 4 and 8. Okay, so they are my factor pairs. They are all the numbers that go into 32. Okay, so they are all our possible measurements. So let's see then, you're going to have to work out the perimeter of each one of those, because the area would be right because they all multiply together to get 32. But a bit like the question before, just because the area is right doesn't mean the perimeter will be right. So if we're doing, for example, 2 and 16, so if this side is 2 and this side is 16, work out your perimeter. Okay, so 16 and 16, 2 and 2, so 2 add 2 is 4, add 16 and 16 together, what will that equal? Okay, work out the perimeter for each of these. Okay, so do what I've just done, but for each of those, and then whichever one is lowest, that will be your answer, because remember it said, what is the minimum length that the path could be? Okay, so work those out. So like I've just done for 2 and 16, add it up, 16, add 16, add 2, add 2, see what it is. For this one, do 32, add 32, add 1, add 1. For this one, do 8, add 8, add 4, add 4. Whichever one is the lowest, that's your answer. Okay, on the bottom of page 52 then, you have got a challenge question. So it says, pentominoes are shapes made by joining 5 whole squares together. At least one edge of each square must touch an edge of another square. 2 pentominoes are shown. How many more can you find? So all the pentominoes have the same area, but which ones have the longest perimeter? Okay, so you have a go then in your purple book at drawing 5 squares joined together in a way like this. So it says at least one edge of each square must touch the edge of another square. Okay, so see how many you can do. I bet you can come up with some brilliant ideas. And then if they've all got the same area because they've all got 5 squares, but then work out the perimeter for each. Okay, so remember the perimeter will be the outside edge of your pentomino. Okay, that's a little challenge for you to have a go at. On page 53 then, question 1 says Christina buys a cubed shaped box of chocolates with a side length of 9 centimetres. It is filled with cube shaped chocolates with side length 3 centimetres. Okay, how many chocolates are there in a full box? Okay, so we're going on to volume now. Okay, and I know that to find the volume, you need to multiply the length by the width by the height. Okay, and remember in a cube, so we've got a cube-shaped box and we've got a cube-shaped chocolate. Remember, in a cube, all of the sides are equal lengths, aren't they? So I've got my box and I've got a chocolate. Okay, so to work out the answer to this question then, first, you're going to have to work out the volume of the box and the volume of the chocolate. Okay, so the box, it said, had a side length of 9. Okay, so if that's 9, then the height is going to be 9 and the width is going to be 9. Okay, so to work out the volume for this one then, you're going to have to do 9 times 9 times 9. Okay, so I know that 9 times 9 is 81. Just 1 second. So then to work out your answer then, you're going to have to do 81 times 9. And you can do short multiplication, can't you? Okay, so 1 times 9 is 9. And then you do your 8 times 9 and add it in there. I don't want to give your answer away. Okay, then for your volume of your chocolate then, it said the side length was 3 centimetres. So if this side is 3, this side is 3, and the height would be 3. Okay, so for volume of the chocolate then would be 3 times 3 times 3, which you can probably do in your head. Okay, once you've got that then, if you do this answer divided by this answer, that will tell you how many chocolates fit into that box. Okay? Question 2 then says, Daniel's cuboid-shaped toy box measures 2 metres by 1 metre by 1 metre. He fills it with cuboid-shaped sponge blocks measuring 1 metre by 0.5 metres by 0.5 metres. What is the maximum number of sponge blocks Daniel can fit in his toy box? Okay, so for this one then, if it's 2 by 1 by 1, then this is the length, this is the width, this is the height. Let's write that on. So length, width, height. Right, same on here. Length, width, height. Okay, so let's do the length first. Okay, so we'll figure out how many he can fit along the length. So to work out the length, let's just scroll down here a little bit. Okay, so to work out the length down here, we need to do 2 divided by 1. Yeah, so if you do 2 divided by 1, that will tell you how many blocks he can fit along the length. Because remember, the box was 2 metres long and the cuboid-shaped sponge blocks were 1 metre long. So if you do 2 divided by 1, that will give you how many he can fit along the length. The width then, so the width was 1 metre wide in the box and the cuboid shaped sponge blocks were 0.5 metres wide. So for this one then, you need to do 1. Oh, sorry, no, we're doing width, aren't we? You need to do 1 divided by 0.5. And then you need to do the same for the height. Okay, so for the height, it was the same measurements. So you need to do 1 divided by 0.5. Okay, once you've got your answers for those then, you then need to multiply those 3 together. Okay, so if you multiply that by that by that, that will give you your answer. Okay? So, question 3 then. So, Michaela sells cubed shaped boxes of nuts with side length of 12 centimetres. She packs them in rectangular crates for shipping, measuring 120 centimetres by 13 by 50. Find the maximum number of boxes that can fit in each crate. So if it's a cube shaped box, we know that that box is 12 by 12 by 12, don't we? Okay. And the rectangular crates are 120 by 13 by 50. Okay. So similar to the question before then. So the length, you would do 120 divided by 12. Okay. So for the width, you would do 13 divided by 12. Okay, you don't need to do a decimal remainder for that one. Okay, so I know that 12 goes into 13 once with 1 left over. So your answer for that one can just be 1 remainder 1. Okay, you'd have 1 left over. So it'd just be 1 box that you could fit in. And then for the height, you would do 50 divided by 12. Okay, because remember, they were the measurements that we had, weren't they? Let's just scroll back up a second. 120 by 13 by 50. Okay, so I've used those measurements and divided it by the 12 centimetres. Okay, so once you've worked out those answers, then very similar to the one before, you need to multiply the full boxes. So for this one, you forget that remainder and you just multiply the 1 by the other answers. Okay, so multiply all 3 answers together and that will give you your answer to the question. Ooh, lots of steps to these questions, isn't there? Okay, your last question then for today is another challenge question, and it says Nicola is building cubes and cuboids out of 1 centimetre cubes. Using 1 cube, she can only make a 1 by 1 by 1 cube. Using 2 cubes, she can only make a 1 by 1 times 2 cuboid. Work out how many different cubes and cuboids she could make with 3, 4, 5, 6, 7, 8, 9 and 10 cubes. What about if she used 16 or 20 cubes? Can you see a link between the number of possible cubes and cuboids and the number of small cubes she uses? Okay, so another little bit of trial and error there. So have a think. If they are 1 centimetre cubes, remember that's some key information, isn't it? So if she can, using 1 cube, she can only make a 1 by 1 by 1 cube. Okay, so if she puts 2 cubes together, that would make a cuboid, wouldn't it? And that's 1 by 1 by 2, isn't it? Yeah? Then have a think, what would happen if you added another cube on? What would it be? 1 by 1 by... Okay, so have a think, have a play about with it and figure out what it would be for all of these different numbers and then see if you can see a link or a pattern. Okay? So that's just another thing to get you thinking, just to challenge you. Okay, so Make sure you try your best on all of your work for today. I know some of it is tricky. Just make sure you persevere and really, really try. And then don't forget to email me if you need any help or to send me your pictures. I love seeing what you get up to in maths. You're all doing brilliantly. See you tomorrow.